Ladies and gentlemen, we are here. We are officially in the future, which is this right here. This is the future of architecture, the future of construction, the future of mass timber. This is a fairly new project in Germany, and it's an airship hangar. It's really cool. I've never seen anything quite like this before. So what do we got? Well, like I said, it's in Mulheim, a town in Germany, and it's made of truss arches made of glulam. And sometimes you see like a simpler version of this, but maybe not on this scale, and not in this kind of crazy half circular dome shape. And we'll get into the details here in a minute, but fairly recent, 2022, and it's pretty big, 3,400 square meters. And to give you an idea of the scale, just the size of this thing, here's a photo with people in it and a massive truck. Look at this, it's like the size of a dump truck, and it's tiny. Look at the people down here, right? This thing is 26 meters tall and 42 meters wide. That's massive. Like, this is, again, it's literally an airship hangar. You can park planes in here. Holds 1,500 people. Interestingly, it's a cool enough space that you can actually rent this out for like weddings, events, things like that. So that's kind of cool. Talked about the height and the span, which are pretty impressive. Shout out to the two architecture firms. The designers were Simp Fischer Architekten, and also a big shout out to the structural engineers, Ripkens Weisenkamper Beratende Ingenieure. Probably butchered that, but it's Germany. What can I say? So, again, super cool building, and there was no real steel used on the whole kind of upper section. And just get a load of those doors. There's something like 72 tons each, something like that, and they're on these big motors, and they kind of wheel out of the way. So super cool. Looks great at night. And like I said, there's no real steel. There is a concrete base in terms of the foundation, and I think there's some steel connectors kind of holding these little archway trusses to the ground, but we'll look at the details here in a minute. Here's kind of a cool view of the outside, again giving you a sense of just the scale of this building, and how it's simple, and I like that. It's doing what it needs to do in terms of function, and it's not kind of going beyond that. You can see these are the doors at the end that open up, right? So you end up with this kind of door over here and another one over here, and this big open space in the middle. And then it's pretty simple in terms of like the construction of this thing. Maybe not the design and the engineering, but the actual putting the pieces together on site. You have a lot of this kind of standing seam, vertical roofing / wall cladding. Some glazing down here at the bottom, but then you just kind of wrap that the whole way around. There'd be some tricky curves and stuff to deal with, certainly when you're looking like up here and up here, you're dealing with some funny shapes. It's curving and tapering at the same time, but relatively simple in terms of like the actual assembly of this thing. Here's a really cool photo as well. It just shows you how simple this thing is. Like, the section here is the same as the section here, same as the section here, almost the same as the section here. You have a slightly different detail here. Again, almost the same as the section here, just a little bit different down to the bottom. And then over here, same kind of thing. It starts to wrap around. So like 80% of this building, if you look at that chunk right there, that's like pretty much the same detail all the way around. And then you just have to turn it, right? So like this is pretty similar and this is pretty similar. So sort of technically, from a design standpoint, it's relatively simple. Probably helped a lot with cost, even though, I don't know, this could have been an expensive building in terms of the engineering and the wood components and things, but who knows? I couldn't find any information on the cost, but that would be interesting to know. So what do we have on the inside? Well, what makes this cool is, I mentioned mass timber, right? This is where you have cross-laminated timber panels and glulam beams, things that are not just like stick frame assembly like you'd see with a traditional house with like a 2x4, 2x4, 2x6. These are massive engineered chunks of lumber, and I'm talking about like this arch up here, right? It's probably, I don't know, 2 pieces, could be more than that. Could have came in like 4 pieces, 6 pieces. Could actually might be more than that. Looking at the scale, that could come on like 10 different trucks, right? Like, those are huge. But anyway, what I'm saying is that giant arch is kind of the definition of mass timber. And you have that repeated the whole thing. So that's basically like the superstructure of this thing. And here's a really good illustration of that. You have all these mass timber trusses, the skeleton, the framework of this building, and then there's another mass timber component, and I'm assuming these are CLT panels, these cross-laminated timber panels. I don't know this for sure, but these horizontal bands, right, that wrap around and fill in those gaps between all these trusses. That's what's kind of adding the rigidity, the horizontal rigidity, the stopping the shear forces from this thing just kind of tipping over. So those are the sort of two major structural components, which again are mass timber, specifically fabricated for this project. I imagine maybe these panels, maybe not. They could be a little more straightforward, but those arches are definitely custom made, probably on the pricier side, but probably comparable to steel when you think about it, because steel's not cheap either. And normally, if a building of this size and scale with these massive 42-meter spans, you would see that in steel. You don't see that in much else. So the fact that you're getting these massive spans and these huge open spaces that are that wide and that tall, so that you can park an airplane in there with wings and whatnot, you're not going to crash into a column. Normally, you use steel for that. So the fact that we are seeing this getting pushed to these extremes and really pushing the limits in terms of engineering, with mass timber, it's great because we're just going to see it in more and more applications, and that's, I think, a good thing because timber and wood is a renewable resource, right? These were all trees at one point, and we had to cut them down, but it's certainly easier on the environment than steel or concrete, something like that. So the more that we can use these engineered mass timber kind of unique buildings, and the more and more we see this stuff, I think it's better for everyone. Pushes design, pushes sustainability, environmental sustainability, all that stuff. So, and again, it's a very cool building. Like, if this is all steel, would you rent it out for a wedding? It wouldn't be quite as warm, as inviting, but the fact that they rent this thing out for special events, I think is super cool, and it just speaks to the material and how much people really like wood and gravitate towards wood because it's a natural material. It's soft, it's warm, it has that texture and those qualities that we like, as opposed to something like concrete or steel, which are nice in their own way, but they're not as warm and inviting as materials. So anyway, I just think the design of this is actually really beautiful, and it really does push wood to the limits, which is great to see. So big fan. What else do we have? We'll look at the structural stuff in a little more depth, and it's very cool. It's just these trusses. This is not unlike what you would see in the attic of your house, right? Where you have, I mean, it's probably not curved at this scale, but it's kind of a simplified version of a truss you would see at your house. And here we're looking at the details a little closer. So again, this probably came in a few different chunks. Zoom out so you can see this thing. There we go. And at the very bottom, you can tell that is some kind of a steel connector. I don't know exactly what that looks like, but or it could be concrete actually. But I'm assuming there's some kind of steel connection that's running down into the concrete, into that foundation, and anchoring it with a knife plate or something up into this vertical portion of the truss. And that's just repeated over and over and over again. And then you have those horizontal bands, which are kind of disappearing in the cladding, right? Like, there's somewhere in there, you have those horizontal chunks, and then you just fill the rest in with wood, and you put some cladding on the outside, and Bob's your uncle, you're done. And here's a little bit of a close-up on these trusses, and again, they're pretty simple. Like, these are huge pieces of wood, but there's just a scaled-up version of what you'd see in your own home. So it's really nothing too groundbreaking. Like, it's just kind of expanding on what we already know, and pushing the engineering and whatnot. And here you can see, actually, this is a better detail of these little connectors. Looks like they're on a pivot, maybe. There's a little joint in there that allows this thing to maybe shift ever so slightly, which is kind of cool. And it gets solid here in the bottom chunk, where it's acting more like a column down to here, where it's essentially vertical, and then starts to curl around and becomes more of a truss. And here's a great detail, and this is super cool because these look like little nail holes, right? Just all these little spots. But when you think about the scale of this piece of wood, like, let's go back and look at that truck in there, right? these are huge pieces of wood. These chunks of timber are absolutely massive. Let's delete that. So when you consider those little dots in there, those aren't nails, those are dowels. So this whole thing's actually held together with other pieces of wood. There's no nails holding this together. The glue lam is glued. That's why they call it glue lam, glue laminated timber. But we have all these little bits that are held together with these little dowels. Let me just delete this and just kind of show you what I mean here. So we have this massive chunk of timber, right? And then this massive chunk of timber. And it's kind of being held together with these little slats in between. But what's going through that and punching through all those like 1, 2, 3, 4, 5, 6 layers, whatever that is, all those little dots are little wooden dowels. And when I say little, like they're probably like the size of your arm. But that is what's actually holding this thing together and pinning it and acting like a nail. So that's a really cool detail. And the fact that they use that instead of steel, because you imagine this would look different if they're giant bolts hanging out all over the place, big steel connectors, maybe some cables spinning back and forth between these things. It would really change the aesthetic of this building, which maybe that's not the most important thing. Maybe it would be fine because it is just an airship hangar. But the fact that they use all wood, maybe just to show that they can, and it does come out with a much sort of cleaner, simpler looking end result, which is you just have wood on the inside. I don't know if these are lights or maybe expansion joints, something like that. But the fact that this is just like basically all wood, it's really incredible. It's a super cool building. Shout out to the architects and the structural engineers for putting this one together. I'd love to see this one in person someday, but I'll have to make a special trip out to the middle of nowhere in Germany, wherever Mulheim is, right? So I'll put a little link in the description to the architects if you want to check out their website and learn a little bit more about this. I also have a video, which is cool. Gives you a little bit more insight as well. So I'll link that down in the description as well. So anyway, just a short little overview on some of the cool things that are happening in mass timber right now and how it is really starting to push back against other materials like steel and concrete and come into its own as a large-scale building material that can have big spans and big heights and really do some cool and interesting things that also look great. So I think we're going to see a lot more mass timber stuff in the future as we push towards more sustainable building materials, things like that. And this is just a great example of, you know, some of the stuff you can make when you do a good job of it. So anyway, thanks for watching. If you're into architecture videos and learning about this kind of stuff, new buildings, different architects, give us a subscribe. I'm going to do lots more of these, and a thumbs up if you found it helpful. So we'll see you in the next one. Thanks for watching, and bye for now.